All right. That's better. Hello, ladies and gentlemen, boys and girls. That took a while to get going. That was. We've got the music back, though, which is nice. We've got the theme tune back, the VUX theme tune. Loving that. Bit of the Supremes, you know what I mean? A little bit of a remix, mixing it up a little bit. Welcome back to VUX World. I'm your host, as always, Kane Sims. And today we have an epic conversation going on with Robert Hallock, who's the Vice President and General Manager of Client AI and Technical Marketing at Intel. Now, Intel, I'm incredibly grateful for Rob and his team, because Intel are actually presenting VUX World for the foreseeable. And so what you're going to learn over the next series of episodes as Intel and VUX partner is all about Intel's new AI PC. And this episode, Rob and I, we're going to get into that, exactly what it is, what it's all about, and you're going to learn a hell of a lot about it. And so, without further ado, let's welcome Rob, shall we? Rob, welcome to VUX World, my friend. How is it going?
Going great. Hello, everyone.
Welcome from nice sunny Austin, who we were just talking about just there.
Yeah, it's awfully sunny right now. For those of you at home, we were just chatting pre-stream. It's like 35 or 40 degrees Celsius right now. Kane thinks that's holiday weather. I'm over it because it's been 3 months of that.
Well, I had to fly 3.5 hours to get that kind of weather 3 weeks ago. So
fair enough.
definitely holiday weather for me. Cool. Welcome, Rob. Thank you for joining us. Appreciate it. We're definitely going to have a really interesting conversation about Intel and the AI PC, which I'm super excited to hear about. As you know, we are very much AI first on this podcast. We tend to talk a lot about applied AI. So once the services have been built, and how do you use the APIs? How do you use the platforms to create and build effective experiences with AI and really great services? This conversation today, as well as discussing the AI PC, we're also going to be talking about some of the infrastructure behind AI, including the chips that are required to process the inference and to train these models. And so I'm really excited to chat with you, Rob, as we go. So why don't we kick off, though, with a bit about yourself, though? Tell us a bit about yourself, what you do at Intel, and a bit about your experience, shall we?
Sure. So I've been at Intel for about a year and in the silicon industry for about 15 at this point. My team handles all the performance analysis of we call them client parts, but that just means end user, consumer facing Intel Core Ultra CPUs. So that could be a mobile chip, it could be a desktop chip. We handle all the data, and we also handle kind of public communication about the technology. Like, what are we working on? How does it work? And why should you care?
Nice. And the whole silicon industry at the minute is going through like a massive boom, isn't it? You know, like obviously we've got a lot of the generative models and large language models that are all using various GPUs. We've got the rise of, or forecasted rise of, more kind of consumer devices and IoT devices, all going to be running various AI models and machine learning models if they're not already. And so explain to us a little bit about, you know, you've worked in this industry for a while, as you've said. What's it been like for you over the last few years? Like, has there been a notable kind of rise in interest, certainly on the silicon side?
It has been an interesting adventure. So I started working on AI silicon. It would have been about 2.5, 3 years ago now. And in the beginning, there was just a lot of, I think, skepticism. It's not often that you bring new hardware, new accelerators inside a CPU, or into the PC in general. Let's just forget the CPU, just new accelerators inside a PC. And history has not been kind to the list of moments that has happened. A lot of those accelerators have fallen off the truck or gotten acquired by someone. So understandably, there was some skepticism early on. But now, 3 years later, I think people are generally coming around to the idea that this AI thing is going to stick around and is beneficial for performance and power, which is, I suppose, why we all buy computers in the first place.
Yes. And could you explain a little bit about kind of, because there's different types of chips, isn't there? You're referring to the kind of chips and processors that are in hardware, PCs and mobile devices, as you mentioned. But also there's chips that run on servers that are used for model inference and stuff like that. Could you give us a bit of, I suppose, a whistle-stop high-level view of the different types of chips that are involved in AI, whether it's training or inference or processing, and how that kind of looks?
Sure. So we'll start with the big one first. On inference and training both on the data center side, you have what are essentially graphics cards or devices that look extremely like a graphics card, just lots of matrix math multiplication happening over and over, and it's a card that goes into a slot, and there might be hundreds of those in a server. And again, you can use that for both training a new AI model or serving inferencing, that is things like chat gpt or stable diffusion over the cloud. Kind of one step down for there, you might have a desktop training device, which might be a desktop PC with multiple graphics cards, kind of the same type you might find in a server, but on a much lower scale. Software developers might use that to build a model, build an app for deployment to the public. And then the type of stuff that I work on and my team works on and people will ultimately buy are these discrete GPUs for consumer computers or processors that both have AI acceleration built in. So we're talking about conventional computer hardware components that have been updated with new capabilities to process AI.
Interesting. So essentially, it's fundamentally the same kind of processes. Is that fair to say? In terms of the
That is
ones,
fair to say.
yeah.
Yeah. Once you get at the level, let's just take a GPU for example, a very common device for training or running AI applications. It's probably the same instruction set or something very similar from big to small. Um, a CPU, an Intel Core Ultra CPU that's in a notebook has the same graphics architecture as a couple $100 discrete graphics gaming card, and the discrete graphics gaming card is substantially more powerful in terms of overall computational capability, but the software effort that we invest in the discrete cards can pay dividends in the mobile CPU side or vice versa. So that commonality is very helpful for people.
Mm, interesting. So the you mentioned CPU, GPU. There's a few different types of kind of processors that have been kind of making headlines recently, with a lot of different companies making, LPUs, language processing units, and RPUs, and all these different types of stuff. Like, is there fundamentally much of a difference in the way that these various processors work? Is it fundamentally the same processor or type of processor in the Intel Core Ultra in terms of what it does and how it works, as comparison to like an NVIDIA GPU that's used to like run the inference on ChatGPT? Like, what's the fundamental difference between the different types?
Ooh, this is a great question. So I'll start with the odd man out first, which is one of these purpose-built accelerators. So in AI land, you can actually build an accelerator that is for one AI model, and that's like a language processing unit, as you gave an example of. So that would be the architecture of that accelerator is built to run only that type of AI model, or perhaps even one model, and that makes it very fast at that one model, but not very general purpose, because it can't do anything but that model. So what we're talking about here is a much more general purpose AI acceleration device, and it comes in a couple flavors. Traditional CPU cores have some amount of vector and matrix math capabilities. That's an instruction set called AVX 256. Um, CPU vendors have the choice of whether or not to include this functionality in their CPU cores, and it can make AI faster if run on the CPU. And many software developers do this because it's the widest available hardware, and maybe their compute performance requirements are not all that high. So that might be five. We'll call it five tops, or 5 tera operations per second, as the low bar. You could step up to a GPU that's built into the processor that might have 60 or 70 tops instead of 5. And then you can go to a discrete GPU, which might have hundreds of tops or even thousands of tops. The GPU inside the processor or in the discrete card are fairly similar. There are architectural differences across the different vendors that make graphics cards, but at a very high level, you're talking about a vector or matrix math engine duplicated over and over and over. All GPUs kind of work that way. Last and newest is called a neural processing unit, or NPU. These are built into all the new CPUs that are available this year, Intel Core Ultra included. And the only thing an NPU does is matrix math. And matrix math underpins AI calculations. So unlike the GPU, it cannot run graphics or general purpose computational workloads. It only does AI. And so NPUs are in all the processors new to the market this year. And in certain cases, they're also available on discrete cards you can plug into PCI Express, but those are rare. And that's kind of the landscape. So you've got CPU at about 5 tops, GPU 60 to 70, and then NPUs this year are 40 to 50 tops. But they have very different performance and power characteristics on the other side.
Right. Okay. So would it be fair to say then that the reason why many of the large AI companies building these foundation models are using GPUs is because they have, as well as being able to process graphics, they can also deal with complex mathematical computations and vector computations, which is perhaps useful or used in training the models, but what it sounds as though you're suggesting is that NPUs, neural processing units, are more effective at inference or running machine learning or AI workloads. Am I understanding that correctly, or have I got something wrong there?
No, that's exactly right. The on the ground now, you'll have inferencing, and I just don't want to assume anybody knows what that means. That just means running an AI model of some kind on your device. That's the simple definition. That inferencing may happen on the CPU, the GPU, or the NPU, depending on what the software vendor wants for performance, power, battery life. But architecturally, a GPU is a GPU and an NPU is an NPU, and they have minor differences that make them more or less efficient. But yeah, they share a lot of common DNA.
Right. That's interesting. And so would it also be fair to say then that some of the as we mentioned earlier on, we mentioned like LPUs and some of these newer type of processors that are designed to do one specific thing or to train or inference on one specific model versus some of the the Nvidias of the world that pretty much, although they do consumer-based graphics cards, their growth has come from essentially graphics cards running on servers that process AI models and stuff like that. Is it fair to say then that Intel's, I suppose, specialism and core focus is essentially processors based on specific devices rather than servers? It's more device based, so it's kind of like the PCs and stuff like that. Is that kind of your kind of key sort of market? Is that fair to say?
That's my key market. Intel does have its Xeon and Gaudi lineup, which both serve AI inferencing and training in the data center. But my day job is Intel Core Ultra, which is the consumer CPU that you can get in desktop or notebook. And so what we're really talking about here is end user applications, models running locally on your PC. This is for inferencing only. You would not build or train a model with this, though you could. It's just unlikely. Yeah, and we're talking updates to applications people probably know well, like, I don't know, Adobe Photoshop, Adobe Premiere, Microsoft Teams. They're gaining new AI features all the time. And we need this silicon. The whole industry needs this silicon to stay ahead on performance and power. It's the next big leap of where performance and power efficiency is going to come from in the industry. So it's a huge effort from not just Intel but all the players, and it's super important.
Definitely. And earlier on, you've mentioned a few times accelerators. When you say accelerators, are you referring to specific chips on processors that have been created for specific purposes that then accelerate the kind of the running of that specific use case, or are you talking about accelerating in general terms? For example, the Intel Core Ultra accelerating, like, what is it, over 300 different kind of workloads in terms of, running some of those AI processes locally. What are you referring to when you talk about accelerators?
That's a great question. So on the CPU side, for convenience sake, we call it an accelerator, but it's really just an instruction set we've added to the CPU to make low latency AI processing faster and easier. So that's not really an accelerator in the conventional definition. On the GPU side, it's a little closer. All of our GPU cores in the new Intel Core Ultra 200V series, which is our new family of chips. The graphics engine, there's 8 cores in the graphics, and each of those cores has a specific AI component bolted onto the end. So there's 8 graphics accelerator, or 8 graphics cores, I guess you could call it, and 8 AI processing cores as well. And that looks more like an accelerator, but the real accelerator is probably the NPU, because it was added to our lineup December of last year, December of 23, and that's the first time we added a specific coprocessor for AI only to the CPU, and that joined the other existing capabilities. So when we say accelerator, we kind of just mean, hey, there's some unique hardware here that's helping with this. It's not just running by default or by accident. We've added something.
Right. And what would be some examples then of the ways in which the Intel Core Ultra NPU would assist in running some of these AI workloads?
So Microsoft Teams or even Zoom is a great example here. If you run the Windows desktop client, they have a number of AI enhanced camera effects that improve the accuracy of this camera feature, where you can blur out behind you or put a fake background behind you. That gets much more accurate and much more power efficient when you do it with AI instead of a conventional algorithm. We can also there's this feature called gaze correction, where if I look away from the camera, which to read a note or something, it will point my eye line back at the camera, and there are other features like this, and people use these features often. The digital background or the fake background is convenient, but it's actually quite intensive for battery life. So after a full day of use, we can actually get about 2.5 hours back of battery life on a PC just by offloading that one feature
Wow.
to an NPU. Um, and then there's Microsoft Copilot, which just debuted to market with a number of artistic and language assistance features, and those all use the NPU as well. And that will be debuting in November for the new Intel Core Ultra CPUs.
Wow. So that means then if I was to use Copilot, I'm in a Word doc and I'm having it draft an initial, I don't know, proposal outline or whatever, then all of that will be utilizing the NPU.
That's correct. That's correct. And in fact, the preponderance of the industry today actually uses the GPU, which is why we spent so much time and attention making the GPU quite fast in AI. So our new NPU goes up to 48 tops, sort of its peak performance, but the GPU is at nearly 70. It's a 67 tops device. So uh, most content creation companies, Adobe, Blackmagic Design, Magix, the companies who are doing photo, video, audio, they're all in on the GPU, and so we need to have both running well on our device if we want to provide good experience and good performance. And interestingly, somewhat uniquely, Intel is the only vendor providing full AI acceleration on CPU, GPU, NPU. And there's like a lot to unpack when I say that because it's a complicated topic, but this is what software developers expect, and we're the only ones currently delivering.
So would that mean then that, let's say, for example, I'm using Premiere Pro to edit a video, it's graphic intensive, so the GPU is being used essentially to render the video and to make sure that when I press play, it plays and there's no stutter and lag and stuff like that. But then all of a sudden I do something like, say, transcribe this video. So now I need to invoke an ASR model that's going to require some inference, and then what would then happen behind the scenes is that would then be taken on by the NPU, while the GPU still just focuses on rendering the video. Would that be an example of how that would work, type of thing?
Our GPU is a little different because we have within. So let's take our full GPU config. It's 8 cores, right? You've got 8. You can essentially split it in half. The one half is for graphics, the other half is for AI, and
Right.
you can actually do both simultaneously. You can run a graphics pipeline and an AI pipeline on the GPU at the same time, and that's what software like Adobe Premiere, Photoshop would do. So you use the raster graphics piece to composite the user interface or the Windows UI or any GPU accelerated effect in the application. But then for the AI accelerated components, those go straight down the AI acceleration pipe in the graphics engine and come out the other side.
Wow. And what would, let's say, Adobe or Microsoft or whoever need to do in order to leverage that processor? Do they need to do anything specifically in how they architect and deploy their software, or does Intel somehow, with some sort of like magic, figure out what's required and offload, intuitively, so to speak?
Yeah. There's a little bit of magic involved, but I guess for those who aren't super plugged into software development, not that I would expect anyone to be, a lot of software development is using what we call middleware or libraries, which are assistive pieces of software that allow software developers to take a shortcut or save time because they can plug something in to their work without having to design it themselves. And AI and gaming and PC gaming both work that way very often. There's a lot of assistive middleware for AI that developers can grab to either design the app or access hardware features or import certain models or compress those models or make them more efficient or smaller for memory. All of these tools and middlewares exist, some designed by Intel, some designed by third parties, and we need to invest effort all the same, no matter who the middleware is from. Intel needs to optimize it and make sure it runs well. And then the dev can use that middleware from the supported list to design what they want to do.
Interesting. And how do you kind of quantify the impact that the Intel Core Ultra has then in comparison to your other processors or competitive processors? Like, what are the metrics that you use to determine, this is actually performing far better? Is it speed? Like, how do you quantify it?
Oh, that's a great question. That is what we actually do in my team, quantifying and measuring. So there's a couple ways. Benchmarking AI. Actually, let me start with a place that people might understand. PC gaming, right? You have a game that runs at a certain number of frames per second, and it consumes a certain amount of power from the system to do that, and that's your performance per watt. So frame rate versus energy is performance per watt, and raw frame rate is your actual performance. And there's lots of ingredients that influence that performance. Was the game engine optimized? Was the game optimized? Does it have a good driver from the GPU company? Okay, so that's gaming. AI is almost exactly the same. Instead of a game engine, you have an AI model. Instead of a game, you have an end user facing application. And you even have drivers for the GPU and the NPU that can enhance performance in those applications. So, how do you measure it? There's a couple ways. If you have a language model that uses a metric called a token rate, that is roughly equal to how many words per second is produced, although a token isn't exactly one word. It might include a space or a period at the end of the word. Um, Also in LLMs, token latency, how quickly do you get the first word is important. So these are all timed in milliseconds for the token latency. And then tokens per second is to count them, tokens per second. On Gen AI, like Stable Diffusion, generating an image, there's a couple metrics there. You can use time to complete, which is the common one. There's also quality metrics. You can heavily influence the output quality depending on what type of math you use. So there are tools now that can actually measure the quality or the comparative quality between two images. And then the last one for a lot of the content creation applications is just simple time to complete. It's a very conventional sort of benchmarking methodology, but it gets significantly faster when you have this AI acceleration built in.
Wow, interesting. Yeah, that sounds very complex and well over my head in terms of being able to work all that sort of stuff out. When you're referring there to, let's say Stable Diffusion, generating images, or a large language model processing and inferring, is it that will the Core Ultra essentially help even if you're running models in the cloud, or would you require the model to be deployed locally on the device?
That's interesting. So there's kind of two ways that software developers have tackled that. First and foremost, there's a huge appetite to just bring them locally on the device. It's more power efficient to do that, to not spin up a server and instead allocate a small CPU, maybe a fraction of its resources to do the job. So transitioning locally is a big thing. There's cost savings as well. Many cloud services for AI simply cost electricity dollars and service dollars that has to be recouped from you as a subscription fee. And moving those workloads to the local PC is possible. It's happening, and uh, things like ChatGPT or Stable Diffusion, which used to be the domain of cloud service only, you can now very comfortably run equivalent functionality right on the local PC without ever going to the cloud. And that has happened very quickly in under 12 months. Um, we've seen that transition from cloud to local very effectively. There's also privacy, right? There's things you just don't want to put on the cloud or can't afford to put on the cloud, and processing it locally would just be safer, smarter, whatever positive word you'd like to use there. But those are the motivations to bring AI locally. But there will always be a role for what we call hybrid cloud, because maybe there is a workload that's just better on the cloud for some reason. And Microsoft has been a good example here. They use a mixture of local and cloud computing for Copilot Plus. And so you need robust local support from a hardware point of view and a software point of view. But sometimes for battery life reasons, it's just easier to go to the cloud if you can afford to wait a couple extra seconds. And so there's room for both in the industry going forward, and that's what you'll see on the PC.
Yeah, that's one of the things that Apple kind of were saying, weren't they, about the recent Siri updates, is that for sort of like routine, easy, simple stuff and maybe device controls and stuff like that, everything's just going to be handled locally with their own sort of customized, fine-tuned model that will essentially probably just be downloaded to your device with the latest iOS update. And then if it's something more intense that requires, greater inference, then it'll ping it off to the cloud type of thing,
That's right.
Do you see the trend being that most, or not most, but like over time, for example, the Adobes of the world, the Zooms of the world, do you see that not just with language models, but also with other machine learning models, that there may be a trend to start, running more things on the edge, more local?
Absolutely. So when I started in my role at Intel, which was late summer of 23, we had about 12 software developers that were interested in designing features for local AI processing. So 12 software developers, around 50 features at the time
Mm,
in August of 23. We are now at over 100 software developers with over, I think we're at 350 features now, something like that. So
wow.
that is 13 months time, a 10x growth in the number of software developers, and like a 6 or 7x growth in the number of features we're supporting and working on with our partners. And that's an insane growth in a year. I've really never seen anything like it in my career, and that's what keeps me actually really excited about this market. It's not often that you add new accelerators or new hardware to the CPU. It's only happened a couple times, and I have the good fortune of being in the right place at the right time to see it happen again. And I think it's going to do good things for energy efficiency and just user performance in general, or features that simply could not be done before, which is the one that excites me the most. I could talk all day about that one.
Yeah. So does that mean, am I understanding you correctly there then? Does that mean that you need to make updates to the processes themselves as more developers and more companies want to deploy more things on the edge? Is that am I correct in understanding that?
Sort of, kind of. It uses a driver. So when you download our graphics engine is called Intel Arc, and when you download the Intel Arc driver, that not just updates the graphics component for playing games, but it also updates the AI functionality as well for better performance and better compatibility. We are one part of the that middleware that helps run AI software, and we can do our own optimization to make sure the experience is better. That driver package for Intel Arc also includes an NPU driver as well, so we can provide stability enhancements, performance enhancements, features enhancements along the way. It's very graphics like and very extensible.
Interesting. I never even thought about that. I thought that you would, you spend all that time researching and creating processes, and then it's built, and then you deploy it, and then it's in devices, and then you're selling laptops, and then that's kind of it basically. But I didn't realize that the driver updates would actually be keeping it going and keeping it improving and keeping it updated. That's a really interesting little insight.
Yeah.
Yeah.
It's an interesting piece because there are the things that are baked and done. So in AI land, there's something called a data type, which is sort of a mathematical representation of a number, and those numbers can be bigger or smaller, and they're defined by names like int8, which stands for 8-bit integer, or fp16, which stands for 16-bit floating point. That just refers to like how many digits before and after a decimal are there, and the more decimals you have, the more accurate the number is, but the more complicated it is to run. So processing those numbers like int8 or fp16, that's sort of hard coded. That's a fundamental truth of the architecture that you've built, and it's immutable. But above that, kind of anything's fair game in the driver.
Right. Interesting. And you were recently at what was it? What was it? The conference IFA in Berlin,
That's right.
and something interesting was
That's
announced there apparently.
Yes. So we introduced a new processor family. I've mentioned it a few times, but it's called the Intel Core Ultra 200V series. It is our latest CPU for notebooks. Um, it has pretty much the best battery life available on the market. We'll start there. That's something that everybody can benefit from. It also currently has the fastest graphics engine in that thin and light notebook market. So kind of 3 to 5 pounds, 14 to 16 inches. It's a very common form factor in the industry. A lot of people still try to play games on that, including myself. So having a fast GPU is great. We're ahead by about 15-ish% versus the next fastest. And then yeah, all this new AI stuff. It's 4 times faster than our last chip for
Wow.
processing AI, and it's a hell of a CPU. It's kind of everything that I would want. In fact, I'm gonna be buying one at the end of the month. Uh,
Do you
like
not do you not get
I
do you not
could.
just get them? You've built the thing. Do you not just get them given to you?
Well, there lots of people want these, and there are units floating around internally at Intel. But I want my team to have first crack at them, and I'll go buy one. But it's time for an upgrade for me, and it's just a fundamentally good CPU. Like even if you don't really care about the AI thing at all, you just want something that's great for productivity, daily driving, long battery life. That's exactly the chip for it. So anyway, it's called the Core Ultra 200V series, and it has a gob of AI performance on top of the fundamentals.
Nice. And this isn't just a consumer PC. Also, it is very much a business PC as well, isn't it? Like people will use these for
Yeah,
work, and obviously, you think about most of the people I imagine, actually, the examples that we've been given, Zoom and Adobe, and these are all professional people.
that's right. Yeah, so our commercial launch, our V Pro models launch next year, and and certainly small businesses don't use the commercial specific vPro models. They just get a consumer model. They see that a lot.
Mm.
But yes, business applications are in fact the sort of the first wave of AI applications that took off. A lot of language assistance, note taking assistance, essentially clerical work can be automated by AI, and that gives you time back to do, I don't know, not writing notes in meeting minutes. Go do something better with that time. But yeah, commercial is very very big right now in AI.
Nice. And when you say people can, small businesses or whatever, or even freelancers or whatever, might just go out and buy an off the shelf one. Are these Intel PCs, or are these PCs that you've partnered with organizations to deploy, like Dell or HP or whatever? Like how will someone get their hands on one of these?
Yeah, it's the traditional model. You can Dell, HP, Lenovo, Asus, MSI, Acer, right? Pick your OEM. They all have one. Um, I should say people may not know OEM. Pick your system manufacturer, and you can probably find one. And it's the Intel Core Ultra 200V series. And there's many models to choose from, depending on your budget or your needs. But yeah, I think they go on sale September 24th, and I think you can pre-order some of them now. Actually,
Wicked. That's next week.
yeah.
Cool. Where is it all going then? Do you think, like, we've spoke a little bit about more more workloads being kind of running on the edge, and that requiring these capabilities and stuff like that, but at all levels, really, there is immense competition. There is loads of funding being pumped into the creation of new types of processors, the Groks of the world, etc., that are just being pumped full of money to try and compete, if you like, in some ways with Intel. And Nvidia's growth has been huge over the last kind of 3 years. Inevitably, there's going to be a forecasted rise in demand for not just the training but also the inference. So a rising demand in processors. But does that just mean more GPUs, more NPUs, or are there any other trends that you see kind of on the horizon that listeners might be interested in?
Well, it probably is more. I think that's the ground truth. I look at research organizations like IDC, who are forecasting a bit of a growth on the back of the AI PC, and it's also worth pointing out that we're coming up on the start of the refresh cycle for the systems that were purchased at the beginning of COVID. The average business PC only lasts 4 to 5 years before being refreshed. So there is sort of this inflection point coming where people awaken to what AI can do, which is a long-term project, and then also the COVID refresh, or I should say the post-COVID refresh. Uh, the other trend is that AI is still very new. Adoption of all technologies happen in a bell curve, and we are certainly still on the uphill side of the bell curve. Businesses are very interested. Power users are of mixed interest. There's some amount of interest and skepticism there. And then I don't even think mainstream users or kind of entry level $500 notebook consumers have even thought about AI yet. So I think the real trend is that AI happens in kind of fits and starts or waves over the next 3 years. And my personal view is that by 2027 or so, we'll see general acceptance, which is every CPU has this, every market segment has this. It's easy to find an application that uses it. It's widely integrated into the test suites for independent reviewers who make hardware recommendations. Um, we're getting there. It's a hill to climb, and we just need to keep moving because this is the future of kind of performance and power. I've said that a lot, but the CPU has taken on many faces over the years. It used to be just a CPU core, and now it does media encode and decode. Now it does graphics. Now it does AI. The CPU has been a very agile and shifting definition over the years, and this is the latest shift, and we need to make sure that we're ahead of the curve. Or, by the time we hit that 3-year mark, if we didn't do it, if we kind of waited on the sideline, we'd be behind in performance and power. We don't want to be in that position. We want to lead now and keep pushing, because users will meet us where we are in time, right? Eventually, the benefit will become undeniable, and even gaming is eventually going to get onto this, which is sort of the last. I think the longest standing holdouts we'll see are the enthusiast gamers, who are broadly skeptical of AI, but will probably come on board when an AI feature of sufficient interest and benefit comes along. So it's a 3-year journey.
Very interesting. Most of what you I suppose, come across as an end consumer, if you like, is you don't often think about the stuff that goes into the equipment that you use, do you? It's like, yes, you might see YouTube reviews about the latest iPhone or the latest Mac or whatever it might, but it's always at that kind of level, isn't it? The latest Dell, and it's kind of like for the consumer that just wants to use the PC, it's kind of that level that they tend to look at. But what they really actually care about is this thing going to run slow in 6 months? Is it actually going to is it going to stand the test of time? Is it going to last me and all that kind of stuff? Is it going to perform well? And the kind of enabler of that is the processor, isn't it? And so I think there's a potential here that what you end up seeing is that over time, as you said, the type of things that you typically do day to day just improve. You're on a Zoom call, and all of a sudden, the blur around someone's head is indistinguishable from a green screen, or not like a green screen, but like a proper background, or like, you're using what, as you said, like Adobe or what have you, and things just start running smoother and faster. And I think it's getting people, once people get used to that level of performance, they obviously don't tend to go back, do they? So it's kind of like, I think I can see it on a consumer level manifesting itself like that, but on a business level, I think that there's a real opportunity there, because if a business is going to replace a whole fleet of laptops in the next year, and they're going to bring in 500 or 3,000 new laptops, what do they think is going to happen with AI? Do they think that over time they're going to be consuming less AI services or more? Obviously, it's going to be more.
It's going to be more.
Yeah. So what are you going to do about it?
Yeah, I think you're right on the consumer side that it will. Yeah, I think the reality is that this will be a performance upgrade and a power upgrade that kind of goes unseen or unacknowledged. It's just there. It's part of the rubric or the calculus that makes up the performance, the price, the reviews, but maybe the user never specifically reads about that capability. Maybe they just hear, yeah, it's fast and yeah, it has great battery life. Well, because we invested the hard work to run those AI workloads efficiently and preserve the battery life, even though it's doing something radically new. But yeah, businesses are specifically considering AI functionality in their tenders, in their RFPs for a system upgrade, because they do have to think about what services their users will be running, not just this year, but for the next 4 or 5 years they have that system. And it is so easy to just go get last year's or the year before's PC for a fire sale price. I understand that. But 4 years out, 5 years out, you might be 10 or 20 times slower than the other CPU you could have bought this year. And that costs money, right? It costs time for your staff, and it leads to frustration and declining satisfaction for IT orgs, and that's it's addressable, right? An AI based or an AI enabled processor could help avoid that.
And how frustrating is it? You know, your computer starts going so slow, and you got to go to your manager, and you're like, oh, this is just a nightmare. But you can't really prove it because they don't work on the PC.
Yeah.
You work on it. So it's like, it takes me 10 minutes to start it up. Every time I've got to fire up this program, I've got to wait 6 minutes. It's like, it's hard to sort of justify the expenditure to get a new one if it's not in line with the renewal timelines. So some people end up just dealing with absolute rubbish, don't they? You know. So this perhaps is one way of ensuring against that, you know.
Yeah, they certainly do. I mean, I've been there in my past. Of course, you just have whatever laptop was on the shelf because that's what IT had. It's not a great feeling.
Yeah.
And that's with conventional applications, right? That's a laptop that felt bad on an everyday app it's supposed to be great at. It didn't even require an accelerator or custom or special hardware to run that feature. So it gets that much slower and that much worse when you don't have it. It's not a great experience. So I hope that if you're out there managing fleets or thinking about the next big refresh, that you do consider an Intel Core Ultra with AI capabilities. And by the way, you talked about consumer education. Our CPUs weren't always called Core Ultra. It used to just be called Intel Core. And we made the switch to Ultra because of the AI capability. All Intel Core Ultra has all the hardware that we are talking about today, all the features we're talking about today. Some are faster, some are slower, but we had to easily communicate that something was new and different here in sort of the one line of text that we get, and that's Intel Core Ultra means AI. So we recognize and appreciate the education difficulty you pointed out as well.
I'm glad you called it Ultra rather than just AI, because every man and his dog is calling everything AI. It would have just been total white noise.
It's true. So true.
Yeah.
This is actually one of the big problems in the AI space. So I say the word AI. What do I mean? Do I mean the cloud service that people are somewhat nervous about? Do I mean training locally on my PC? Do I mean Intel Core Ultra? Do I mean something that's not AI that some company is just calling AI? Like, there's so much going on in this space, and it all has the same name. That's a challenge.
And even the people that work in AI haven't got consensus over the actual definition of artificial intelligence. You know?
That is true as well. Yeah.
So it's like, if there isn't a consensus about what it actually means, then it's it's one of them things where everything's .ai or this AI, that AI, and it can become white noise. But good for us, working in the industry, the interest in it and all that kind of stuff is getting there. I think the interest in terms of the models, what they're capable of, their use cases, how they can be applied to businesses, all of that has definitely shifted and grown tremendously in the last 2 years. And I think the next level of understanding and education beyond the models and the business use cases is actually as a user of various systems and technologies on a day-to-day basis, raising that education about actually how AI, running AI models and machine learning models can actually be improved by having better hardware, basically. So it's that kind of completes the picture, doesn't it?
It does, and we recognize that the need for education continues. A lot of what my team does is actually content like this, just so people are aware of what AI is and can do. And it's yeah, I'm in marketing, and my job is to market things, but at the same time, this is such a new radical shift, and people understandably have questions, and my team spends a lot of time trying to help people out in that dimension, not to sell any one thing, but just to get people aware and thinking. um more importantly, I think that we're trying to move this AI conversation very quickly to something that feels more familiar, which is simple performance tests. Maybe it's power, maybe it's time, maybe it's the tokens per second we talked about, but get out of the abstract, which is what is an AI PC, and get to the specific, which is, hey, here's a feature, it does this thing, and it takes this long to run on our hardware versus that other guy. Um, we think that's more familiar territory for people, easier to wrap your head around, and you don't have to understand AI in particular to digest those numbers. So that's where we're moving very quickly.
Brilliant. Well, you've certainly made it easier for me to wrap my head around, Rob. So thank you very much. And if you've done that, then I'm sure you've done the same thing for our listeners. So appreciate you joining us. It's been an absolute pleasure. And if you are tuning in and wanting to know more about this, and you want to know more about the AI PC and how that might be applicable for your business, then to learn more, you can go to vux.la/Intel. vux.la/Intel. Rob, thank you so much for joining me. It's been an absolute pleasure, my friend.
Thank you very much for having me, and we'll talk soon.
Nice one. See you all on the next one. Thanks very much now. Bye-bye.